Imagine you're holding your smartphone. Familiar, essential, always within reach. It's more than just a device for calls, texts, or scrolling through social media. It's your camera, your wallet, your map, and your connection to the world. But have you ever wondered what really lies beneath its sleek surface? Deep inside, a silent battle is raging. A technological war between the United States and China for control over the future of technology. This conflict isn't fought with soldiers or tanks, but with innovation, policy, and the relentless pursuit of dominance in the digital realm. This isn't just about who makes the best phone or the fastest processor, it's about who gets to set the rules for the digital age. The stakes are high, and the outcome will affect how we live, work, and communicate for generations. At the heart of this struggle is the semiconductor chip, the tiny, intricate foundation of our modern world. These chips power everything from the internet and smartphones to medical equipment, cars, and even household appliances. Without them, our digital lives would come to a standstill. The outcome of this invisible war will determine who leads the next wave of innovation, from artificial intelligence to quantum computing, and who shapes global power for decades to come. The race is on, and every breakthrough could tip the balance. Every policy decision, whether it's restricting software, limiting mineral exports, or tightening security, sends shockwaves through global supply chains. The effects ripple out, impacting industries, economies, and even the devices in your hand. Your phone is more than a tool, it's a front line in a global contest for technological dominance. Each swipe, tap, and notification is made possible by a complex web of international cooperation and competition. Its components tell a story of interdependence and rivalry, of rare earth minerals mined across continents and chips designed in one country but manufactured in another. Every part has a journey, and every journey is shaped by this invisible war. Understanding this story is key to understanding the forces shaping our world. It's about more than technology. It's about economics, politics, and the future of global society. This isn't just a tech story, it's about power, control, and the future we're building, one tiny chip at a time. The choices made today will echo for years, influencing everything from innovation to international relations. Welcome to the invisible war in your pocket. The next time you pick up your phone, remember, you're holding a piece of the world's most high-stakes competition, one that's shaping the destiny of us all. What are semiconductors? Think of them as the brains of every electronic device. These tiny, complex switches control electricity, enabling calculations, storage, and commands. Without them, our digital world would vanish. Made from silicon, their creation involves hundreds of precise steps and machinery. The most advanced chips have features smaller than a virus, packing billions of transistors onto a sliver of silicon. Semiconductors drive a multi-trillion-dollar digital economy and are vital for infrastructure and national defense. No single country controls the entire process. A chip might be designed in the US, made in Taiwan, and assembled in China. This global cooperation makes technology accessible but also creates vulnerabilities. A disruption anywhere can halt the entire system, as recent events have shown. The world's reliance on semiconductors is total and fragile. The chip is the unsung hero and the battleground. The chip war is the result of years of rising tension between the US and China. The US has long led in chip design, with companies like NVIDIA and Intel setting the pace. China, through massive investment, is racing to catch up and reduce its reliance on foreign tech. Washington sees this as a direct challenge, responding with strict export controls to slow China's progress in advanced technologies. The US barred sales of high-end chips and equipment to China, creating a technological choke point. China responded by accelerating self-sufficiency and leveraging its own strengths in the supply chain. The conflict expanded beyond chips to the raw materials that make them possible. The stage was set for a new phase of the tech war. China's ace in the global technology race is its overwhelming dominance over rare earth elements. 17 unique metals that are absolutely essential for the production of high-tech products we use every day, from smartphones to satellites. These elements might sound exotic, but they're the backbone of modern innovation. Despite their name, rare earth minerals aren't actually scarce in the Earth's crust. What makes them rare is the difficulty and expense of extracting and refining them. The process is highly technical, environmentally challenging, and requires specialized expertise. Over the past few decades, China has invested heavily in this sector and now controls nearly all global refining capacity. Rare earths are the unsung heroes behind powerful magnets in electric vehicles, the generators in wind turbines, the clarity of fiber optic cables, and the precision of semiconductor manufacturing. Without them, much of our green technology and digital infrastructure would grind to a halt. Today, China supplies over 60% of the world's rare earth mining, and an astonishing 90% of the processing. This near monopoly gives Beijing enormous leverage over global supply chains, making other countries vulnerable to sudden disruptions. By threatening or restricting exports, China can instantly disrupt manufacturing worldwide, halting production lines for everything from cars to consumer electronics. This isn't just a hypothetical scenario. China has flexed this muscle before. Past export restrictions have triggered dramatic price spikes, market panic, and forced companies to scramble for alternative sources. In 2025, China responded to US chip restrictions by imposing new export quotas on rare earths, specifically targeting materials vital for defense systems and advanced semiconductors. The move sent shockwaves through global markets. The message from Beijing was unmistakable. If you cut us off from your technology, we'll cut you off from the materials your technology depends on. It was a clear warning to the West. The impact was immediate and profound, exposing just how dependent Western economies are on Chinese supply. Governments and companies rushed to secure alternative sources, sparking a global scramble for rare earths. In this escalating tech war, rare earths have become more than just minerals. They're a powerful bargaining chip, shaping the future of global power and industry. While China holds sway over the world's supply of critical minerals, the United States dominates a different, equally crucial choke point in the global technology race: software. Specifically, the software that makes the design and creation of advanced microchips possible. Electronic design automation, or EDA tools, are the invisible architects behind every modern chip. These sophisticated programs are the brains that design the brains, essential for creating the complex, tiny circuits that power everything from smartphones to supercomputers. Without EDA tools, the process of designing a chip would be impossibly slow and error-prone. American firms like Synopsys and Cadence, along with Siemens EDA, control over 90% of the global EDA market. Their software is the industry standard, relied upon by chip designers worldwide. No matter where a chip is physically manufactured, whether in Taiwan, South Korea, or elsewhere, it's almost certain that American EDA software played a central role in its design. This gives the US a unique and powerful position in the global semiconductor supply chain. Recognizing this leverage, the US government has made EDA tools a cornerstone of its export controls. By banning the sale of advanced EDA software to China for cutting-edge chip designs, Washington is effectively limiting China's access to the most advanced chip-making capabilities. This move directly caps China's ability to design next-generation processors, especially those needed for artificial intelligence, high-performance computing, and supercomputing, areas critical for economic and military power. In response, China is racing to develop its own EDA tools, pouring billions into research and startups. But despite these efforts, Chinese firms remain years behind their American counterparts, facing steep technical and knowledge barriers. Replicating these platforms is a monumental challenge. It requires not just software expertise, but also deep integration of science, engineering, and decades of accumulated know-how, something that can't be easily or quickly copied. By controlling the digital blueprints that underpin chip design, the US has effectively put a ceiling on China's chip ambitions, limiting how far and how fast Chinese technology can advance. This software blockade is a precise, powerful tool in the ongoing tech war, a digital barrier that's difficult to bypass and even harder to dismantle. For China, the challenge is clear. It's a race to catch up, to innovate, or perhaps even to reinvent the wheel entirely in order to break free from American software dominance. In the end, the battle for technological supremacy is as much about code as it is about silicon. The future of innovation will be decided not just in factories but in lines of code and the software that shapes tomorrow's chips. By spring 2025, the tech war reached a tense equilibrium. The US tightened controls on EDA software and chip equipment, while China restricted rare earth exports. Both sides suffered. US companies lost access to China's market, and Chinese firms struggled to get key components. Quiet diplomatic talks led to a fragile, unspoken compromise, a tech-for-resources swap. The US eased some restrictions on older chip equipment. China loosened rare earth export approvals. Prices stabilized and supply chains breathed a little easier. Both sides recognized their deep interdependence, but the underlying conflict remained unresolved. The world was left in suspense, waiting for the next move. The truce was fragile, the rivalry undiminished. The tech war was far from over. The truce didn't slow China's drive for technological self-sufficiency. US restrictions became a catalyst, fueling a national push to build a complete independent semiconductor supply chain. China invested heavily in legacy chips, older, reliable tech used in cars and appliances, to dominate a huge market segment and fund advanced research. At the same time, China is embracing open-source alternatives like RISC-V, aiming to bypass US software controls. The goal, a homegrown chip ecosystem immune to foreign pressure. Building this is a monumental challenge, requiring mastery of design, manufacturing, and specialized materials. But China's determination and resources are formidable. The race for self-sufficiency is a marathon, not a sprint. China is settling in for the long haul, reshaping the global tech landscape. The world is watching to see if it can succeed. The chip war isn't just a battle between superpowers, it affects us all. For consumers, it means higher prices and less availability for electronics as companies navigate disrupted supply chains. The era of ever cheaper, ever faster devices may be ending. Countries are reshoring chip production, creating jobs but also fragmenting the global economy. The efficient, globalized supply chain is giving way to regional, security-focused models. China's push into legacy chips could flood the market, driving down prices and sparking new trade disputes. Companies and countries are being forced to pick sides, creating a digital Iron Curtain. The conflict threatens the open, collaborative model that fueled decades of innovation. When technology is walled off, progress slows for everyone. Global challenges, from climate change to disease, require cooperation, not fragmentation. The future of innovation depends on how this conflict is resolved. We stand at a pivotal moment. The US leverages its design and software dominance, rallying allies and reshoring manufacturing. China counters with control over raw materials and a determined push for self-reliance. Both sides are deeply intertwined. Total separation would be catastrophic. Fragile truces and uneasy compromises are the new normal. The world faces a tense dance of competition and codependence. Who will set the standards and control the platforms of tomorrow? The US, China, or a fractured digital world? The answer isn't written yet. Who do you think will own the future?